Students, hello, good morning everyone. So, in the last class, we were discussing regarding the truss. Yes or no? Yes or no? So today, are you hearing me, everyone?
Yes, sir.
So today, what we'll discuss the basics of stress and strain. Okay. So we'll be discussing the basics of stress and strain. Now, have you heard of the term stress and strain?
Sir.
Hmm? Has any one of you heard the term stress and strain?
Yes, sir.
What, if yes, then tell me what is that?
Stress means, sir,
Hmm.
expanding, sir.
Not expanding.
Expanding and compressing of something.
No,
Stress.
give me a adequate, appropriate definition, na?
Sir, stress is when something is suspended from a thread and the thread
No, 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 no,
the
no. Anything else? Anyone?
Means, sir, uh,
What you said, Temazar?
means
I'm not.
sports, sir.
In
Stain means mark, sir. Something mark.
no, 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 no. You are all giving wrong.
Stainless steel, like, sir.
No, you are giving wrong definitions. Hmm? Okay, let us discuss about stress and strain. Hmm. So what is stress? Now look, due to the effect of external forces on a rigid body, an internal resistance is created per unit area within the body to resist the deformation, which is called stress. Now I'm telling you one example. Suppose some force is applied on our body, but then initially the body does not get deformed, right? Yes or no? So the body does not get deformed. That means what? The body is resisting the deformation. Hmm? So how does it resist that deformation? Actually, that is known as stress. Okay. So now, if you see from definition point of view, stress can be defined as force applied per unit area. Hmm. That means what? Force by effective area or force applied or force divided by what? Area. Okay. Stress is what? Force per unit area. Hmm. Now the unit of stress is what? Pascal or Newton per meter square. Why Newton per meter square? Because the unit of force is what? The unit of force is Newton. Now, since the formula of stress itself says that it is force per unit area, that means what? We can write it as Newton, then area will be in what? Meter square, right? Then area will be in meter square. Now, if area will be in meter square, that means what? It will be in Newton per meter square. Simple. Are you getting me what I'm saying? So this is what is called force. Force is stress. Stress. Stress is called force per unit area. Now, if you see these figures, now what will happen? This, as the definition says, some internal resistance is created, right? Some internal resistance is created per unit area within the body to resist its deformation. Now, if you can see, suppose this body is experiencing this and this. These are the two forces, right? So now, if these are the two forces acting on the body, then what will happen? You are pulling the body from both sides in this direction and in this direction. Now, eventually, what will happen? Eventually, what will happen? This at a certain section, suppose I'm sorry, at a certain section, suppose XX, at this type of section, suppose XX, what will happen? There will be one force acting on this side and the other will be acting on this side, right? So there will be two forces acting on two different sides. Huh? What will happen? From this side it will be applied here, from this side it will be applied here. Now, now that means what? That means what? Look, if you see here in this side, this the pull from this side is offering, I mean, there is a pull from this side. So for this pull, the resistance is offered from this side, right? Huh? In this case, in the section XX, now in this other section, what will happen? There will be a pull from this side for the force that is being pulled from here. Okay, for the force that is being pulled from here, there will be a pull from this side. So what will happen is that these two are the resisting forces that are being applied. Now when you combine this will look like this figure, the last figure. So this will look like this figure. Okay, if this will look like this figure, then there is one resisting force here, the other resisting force here. So this is what the basic principle how stress will act. Okay, now this is force is tensile. Why tensile? I'm telling you, because it is being pulled. If you see the direction of the arrow, it is in this direction and it is in direction. So both side is what? There is one pull. That means what? This is tensile. But Had it been in the opposite side, but had it been in the opposite side, then this could have been compressive. Just try to understand it. Are you understanding this now? Are you understanding this? I'm
Yes.
asking every one of you. Compressive, tensile, these things. So this is what? This is tensile. Now if the arrows would have been in this direction, then it would have been what? Compressive. Okay. Then it would have been what? Compressive. So this is a typical example of normal stress. Now look, let us understand few definitions. First of all, what is normal stress? The intensity of force normal to the section. Huh. The intensity of force which is normal to the section is known as normal stress. Now that means what? Suppose if you take this example. Now look, stress as we know, as it is defined, it is force per unit area, right? So this is the unit area, right? So this area will be considered. Now this is the force. Now look, this is what? Perpendicular. So it is known as what? Normal stress. Got it? So that means what? If the force is normal to the section, huh? If the force is normal, that means what? This force, okay, is what? It is normal, right? It is normal. So that means what? It is called normal stress. Now the normal stress that causes tension is called tensile stress, and if it causes compression, it is called compressive stress. Now, as for example here, okay. So as for example here, what happens in this figure, the above figure, number D 3.53. So what will happen here? Here it is in outward direction. That means what? You are giving it a pull, not push. Huh? This means what? This is called tensile stress, right? So this is called tensile stress. Again, here it will be a pull. So this is what? This is this tensile. Now, for the system to be compressive, if you think that, if you consider that this is known as what happened, Atung Donum, I have not asked you to give the attendance, right? In this time, I won't consider the attendance right now. I'll consider it once after I say. Okay, just remember that thing. Simply coming to the class and giving attendance won't do. Now, what happens is that we discussed what? We discussed tensile stress. Now we have to discuss compressive stress, right? How to discuss compressive stress? Hmm. Now, if you are applying a push, not a pull, okay? If you are applying a push here and here, Suppose you are applying push. This push, that means what? You are compressing it, right? You are giving it a push, then eventually its area might reduce. So you are compressing it. So this thing is known as compressive stress. Okay. So conventionally it is expressed by what? Sigma equal to force per unit area. So this is how it is being expressed. Now let us go to the next one. What is what? Bearing stress. Okay. Now what is bearing stress? Bearing stress is uh, what is bearing stress? Suppose two plates of thickness T, are held together by nut and bolt. So two plates having thickness T are held together by nut and bolt. Do you know what is nut and bolt? Can anyone say me?
Yes.
What?
Join here it used to join two plates.
Hmm?
Knot and bolts are
Hmm.
uh,
Hmm.
it is object which used to join some things or some in mechanical.
What? Can you give me an example? How? Uh, uh, like, can you give me an example?
Like,
Can you give me an example, Temazan?
there are a lot of example. We use knot and bolt in
Where?
bike also.
Not bike. Look, you are joining. Suppose two plates. You are using night and ball in bike. I am not saying about it, but then these things are like they are a different mechanism, na? So, can you recall? Suppose I'm telling you an example, huh? Uh, in joining two plates, if you see bridges, huh? If you see the bridges, especially the bridges which are made up of steel. So, uh, if the bridges are made up of steel, suppose, then what happens? In order to join two panels, na? In order to join two panels, what happens is that they use nuts and bolt. Got it? So there will be a stress that is be arising, which is known as nut and which is known as bearing stress. Okay. Suppose I'm giving an example. Suppose this is one plate, and this is another plate. Now these two plates are being joined by balls. So here what will happen? They will be subjected to what? Equal and opposite forces. That is P. Huh? So this average intensity of pressure is how it is obtained by force transmitted by the projected area of the ball on the plate. That means what? This bolt, this thing, will be transmitting some force. Now the area that is occupied by the bolt, the area that is occupied by the bolt, that area will be considered. So how it will be given? Bearing stress is equal to P by D divided by T. Okay. Now we are going to what? Stress and strain of shear stress. What is basically shear stress? If the force is acting parallel to the plane of the area, so how it will be acting? This force, this is acting in this plane, and this force is acting in this plane. Now look, this force has the tendency, if you apply these two forces from this side and this side, what will eventually happen? This will have a tendency of tearing this whole thing apart, right? This will have a tendency of tearing this whole thing apart, right? Now if this will have a tendency of tearing this whole thing apart, then what will happen? Eventually this thing will be teared up. So now what will happen? This thing will get teared up and there will be deformation along this plane. So now that means what? This is known as shear stress. That means what? In shear stress, the force, we have the tendency to simply tear off, okay? Simply tear off the bodies. Now because of this thing, what will happen? Now this is joint here now. Now this is joined here now using a bolt. Now if this is joined here, then what will happen? Once shear stress is applied, it will experience the stress here and eventually got torn out. So this type of force or this type of stress is shear stress. So it is denoted by tau. Remember, normal stress is denoted by sigma, but shear stress is denoted by tau. Tau equal to P by As. Okay. So these are certain examples of what do you call it? Shear
Sir,
failure. Now, say
can you explain it again, sir?
this shear stress part.
Yes.
Okay, I'll explain it to you. Look at this figure and this figure, right? Now what will happen? You are applying force, huh? You are applying force from this side, right? That means what? You are pulling this. If this is a ball that is connecting the two plates, right? So now what will happen? In case of shear stress, the force is acting parallel to the plane of the area. That means what? This is one and this is other. That means these two are what? Parallel force, right? If these two are the parallel forces, then what will happen? what will happen? This will, you are applying force here, you are applying force here. Look at this deformation. Look at this deformation of the figure in the second figure. I mean 3.54. So what's there in the second figure 3.54? It gets deformed, right? If this gets deformed, then eventually this is experiencing what? Shear force. So shear stress means what? The stress that is applied, the stress that is being applied on a body which has a tendency to move fast over one another. That means what? This, if you are applying force here and if you are applying force here, then eventually what will happen? It is just tearing off, right? It is just tearing off this thing, and you are just, this thing is just breaking away in this point, right? So this means what? This is not normal stress, but this is shear stress. Is it clear now, Temazar?
Force we applying are nor normal, I think, sir.
Yeah.
So it's come
Suppose you
under
are,
normal.
no, wait now. These forces are acting parallel to the plane of the area. This force is normal to this plane. But if you apply the force here, if you apply force here, now since this is not a combined thing, so this will definitely be parallel to this, na? This plane, and it is being turned at this plane only, right?
Yes, sir.
Ah, yes or no? Are you getting now?
For now, it's okay, sir. I will
Hmm.
clear it by myself, sir.
Hmm. What about others? What about others?
Yeah.
Okay. So now this is how it is happening, this here. Now strain. We'll go to the next topic, strain. Strain means what? Stress is what? Force per unit area. Yes or no? You know, stress is force per unit area. Now strain. There is another term called strain. Strain means what? Change in length, ratio of, yeah. Wakilo Sanki, do you have any doubt? You have raised your hand. Wakila Solanki, do you have any doubts? You have raised your hands. Yeah, can you respond, please? You raise your. Someone has raised their hand. No, no response. So now let us go to the next topic, strain. So what is strain? Strain is change in unit length per unit length, original length. Suppose I'm giving you an example. Suppose I'm giving you an example, okay? Just a minute, wait a minute. Strain means what? Change in length per unit length. Now how it is relevant. Now if you see strain, suppose you are applying some force on a particular body. Huh? If you are applying some force on the particular body, then what will happen? So what will happen? It will experience some change in their dimensions. Okay. So how will that dimensions change now? So how will that dimension change? I'm just telling you. Okay, 1 minute. Can you see the screen?
Sir.
Can you see the screen?
No, sir.
No,
No, sir. We can't see.
Okay, just a minute.
nothing, sir.
Nothing. Give me a minute. Right now, can you see an image?
Yes, sir.
Okay, so ignore this large stress, small stress thing, ignore it. Huh? I'm just telling you a basic example. Now look, what is strain? Strain is change in length divided by original length. That means what deformation. That means deformation by original. So what will happen? Suppose this is L. This is L. Now you are applying some amount of force here, right? Now if you are applying some amount of force here, then what will happen? The length will eventually reduce because of the application of the force. Yes or no? Yes or no? Hmm?
Yes, sir.
Yes, sir.
So if the length will
Yes, sir.
automatically reduce, then what will happen? Suppose initial length was L naught, the original length. Now after reducing, it becomes L. And so as per definition of strain, what will happen? It will be L naught minus L, because we have to find out what? Change in length. Yes or no? From the definition, you can see that we have to find out what? Change in length, right? So if we have to find out change in length, then that means what? L naught minus L. The initial length was L naught. This one. This one was the initial length, right? and after that it gets reduced. So this length is what? L. Change in length divided by what? Original length. This is what? Uh-oh. Uh-huh. Sorry.
Strain.
Yes, this is what? Strain. This is called strain. So that means strain is given by this. Or you can write what? This. This means what? L naught minus L is what? This part, right? Yes or no? So you can write it simply as del L by L. Yes or no? Or maybe
Yes.
del L naught by L naught. Yes? Are you getting me? Everyone?
Yes, sir.
Whatever.
Yes, sir.
Kabom, you got? Okay.
Yes,
What
sir.
about others?
Uh,
Got it. What is strain actually? Got it. What is strain?
sir.
Someone said they didn't understand. Remodasi. Did you understand now? Remodasi. Did you understand?
Sir, this in strain, so the force we give is
I'm
we
not
are
getting.
pushing the
Can you
object
please repeat it?
so that
Repeat
it
it.
reduces length.
Can you repeat it? Your
In
question
strain,
again?
sir, in strain, sir,
Yeah. Uh,
do we
uh.
compress the object so that it reduces in length?
Yeah. In strain, we have to compress the object, no? So that it
And in
reduces.
stress, so we have to pull the object.
No. That is not thing. Strain and stress are totally different things. I'm telling you. So strain and stress are totally different things. Huh? Now what is stress? Stress is what? Stress is force per unit area. That means what? You are applying some force. Now that force which is applied per unit area is known as what? Stress. You got it or not?
Sir, I got it. The stress about this strain, sir.
About
So it is
you
changing
got it
length
about you
means
understand?
we have to deform the body.
Yeah, you have to deform the body.
Yes, sir. Yes, sir.
I'm showing
Yes,
you
sir.
one another presentation. Wait, give me a minute. I'm sharing my slides. I'm showing you another presentation. Wait, you will understand from it much better way. Okay, look at this diagram. Are you able to see? Yeah, are you able to see, students?
Yes, sir.
Yeah, length can increase also. Definitely, Kobam. Length can increase also. Look, so here in this case, as Kobam said, the length has increased. Yes or no? So initially it was L0. After pulling it or after applying some tensile force, this is tensile force, right? If you pull it, then it is increased by how much? Del L. Kobam, can you see it? Hello.
Yes, sir.
Okay. So look, you asked me now for increase in length. So look,
Yes.
here a force is applied and eventually the length is increased by how much? Del L. Are you getting me? Del L means what? It is increased by a little bit amount. Huh? If it is increased by a little bit amount, let us consider it as del L. So what was the original length? L. Change in length
Yeah.
was what was? Del L. So strain sigma epsilon, this strain is given by what? This is the expression for strain, del L by L. Is it clear? I'm asking once again. Is it clear for you all?
Yes, sir. It's
Hmm?
clear.
Uh,
Yes, sir.
Good.
Yes, sir.
So now, can you say me what is the unit of strain? What will be the unit of strain? Can anyone say me?
Unitless.
Hmm?
Meter. Unitless.
No
Unitless.
unit.
Very good. Very good. It is no, doesn't have any unit. Why it doesn't have any unit? Look,
Yes.
del L is in meter change in length, and L is also in meter, right? So eventually
Yes, sir.
it will get cancelled. So remember one thing: unit of stress is Pascal or force Newton per meter square, and unit of strain is what? Unitless. This is a very important question. Everywhere it is asked. Is it clear, students?
sir, one example of stain, sir, I will ask.
You need one example.
Sir, I will give
You want to
questions.
please?
You have to give that.
I have to give the answer. Oh my god.
Yes, sir. We are
What you
uh,
need? What you are asking me?
watching. We see a lot of stain words in like knife, stainless, and
That is a different
in
thing.
watch. Back of the watch stainless, sir.
I got it. I got
Is
it.
that any relevance, sir?
That is stain, and this is strain. Look at the spelling. If you check your knife or if you check your watch, you will see it is stainless steel. STAIN. It is stain. Stain means what? You still pay. It doesn't got get rusted. That is a different thing. Huh? That is stain. If you check out the spelling, just check the spelling of both this. We are discussing strain. STRAIN. And that spelling is STAIN, stainless. हाँ समझ में आ
Sir,
रहा है
one more question.
समझ
Yes,
में
sir.
आ रहा है अभी तेमज़
One more question.
हाँ
हाँ हाँ
पूछो
sir, आ रहा
पूछो
है. Yes sir. Last previous वाला so आज आप जो presentation भेजा था previous presentation one, not the last one. So I watch the word stress by
हाँ हाँ I'm not able to hear you तेमज़ I'm not able to hear you hello
is
please write in the chat
that strong. Small is equal to weak, sir. Can you explain that?
which one I'm not able to hear you तेमज़ can you please repeat
Hello. Hello. Presentation, sir. No, previous one, sir. Not
हाँ
last one. Previous one.
हाँ
In this class, I seen that stress and strain.
हाँ
Stress by strain is equal to large implies to strong. Small implies like
oh
weak,
that
sir.
one
Can you
large
explain
stress
that,
large
sir?
strain
Ah,
I'm telling you now ignore that thing
yes, sir.
that is just for illustration nothing else I got you you said this one na and
Okay, sir.
you said this one na just a minute uh, I got it. I understood which one you asked. Wait, give me a minute. Can you see the slide? Yeah, others please write your
Yes, sir.
attendance. Huh? Others please write your attendance. This meeting will get finished.
Yeah.
This one, na? Same other? Hello? Hello?
Yes, sir. Yes, sir. Bottom one.
Not the large and small. That means what? If large amount of force is applied, then it causes large stress. And if large amount of force is applied, large strain. Ignore this thing. Just I am giving you for reference. No need to look at these terms. Large, small, large, small. Strong material is for large, small is this is a different illustration. I'm just trying to explain you from this figure how it causes the deformation. Okay, you're getting me, Temazar?
Yes. Okay. Okay, sir.
Ignore this. Do not consider this thing. Huh? Is it clear now? Is it clear, everyone? I'm asking everyone. Is
Sir.
it clear,
Yes, sir.
students?
Yes, sir.
Okay, give me your attendance,
Uh,
everyone.